Hi everyone, this is Manas, your friend and tutor, and guys, I'm back with another video on engineering drawing. Today, it's going to be a very important topic, that is Vernier scales, and this is something which was requested to be by a lot of subscribers and our students. So here it is. Now, in order to understand Vernier scales, you need to have some idea regarding plane as well as diagonal scales. As in, plane scale was good enough to measure two different dimensions simultaneously, and at the same time diagonal scales was easily able to measure three different dimensions, say kilometer, meter and centimeter, right? This Vernier scale is also in the same path of diagonal scales, but the one thing which separates itself or separates it from diagonal scale is the use of a Vernier scale, and I'll explain you in detail what this Vernier scale is all about and how very small dimensions can be easily measured. So first of all, let us take a look at a demonstration, rather an animation, which is going to help you understand the concept of Vernier. And here we go. Well, let's draw a line. This line is, let's say, 10 centimeters long, or in millimeters, this can be regarded as 100 millimeters. What we'll try to do now is we'll try to divide this line into 10 equal parts, and it's going to be something like this. Okay. When you divide this line into 10 equal parts, each division over here will represent 10 millimeters, isn't it? Now, if I were to say you, well, you can clearly see 10 millimeter divisions. Can you see 1 millimeter division? Can you see 2 millimeter divisions? Well, you certainly cannot. How to do this, and how does Vernier come into the picture? Well, that's something which is the agenda, which is the objective of this particular video. So what we are going to do is just watch from here. Please see where the cursor is. I've just drawn a line, produced a line from this point over here. Okay. Now the length of this line is equal to the length of this line, or length of one division, that is 10 millimeters. Fine. Let me produce a line in the upward direction from this point and from this point. Okay. And let me finish this. Now the height, this height is 10 millimeters, this height is also 10 millimeters, right? What we are going to do is we are going to divide this OB portion into 10 equal parts, and you can clearly see this OA portion was 100 millimeters long, and therefore this extension is how much? 10 millimeters. So OB will be 100 plus 10, that is 110 millimeters. Now 110 millimeters, you've got to divide this into 10 equal parts, and you have to use the line division technique. It's something like this. Just draw a line randomly, preferably at an angle of 45 degrees or 30 degrees, whatever, and then keep on making arcs, okay, of equal radii. How many arcs? Well, how many divisions? Number of divisions are 10, therefore the number of arcs that needs to be put up is 10. How many? Yeah, done. Now this 10th arc has to be joined with the end of the line. Okay, the end of the line started over here at B, and it's gonna end at O. So this 10th arc has to be joined with O. Now place your mini drafter along this line. Okay, tighten the screw and bring it over to this 9th point. Again draw a line. You'll see a line absolutely parallel to the previous one. Keep on repeating this process for 8th, 7th, 6th, 5th, 4th, 3rd, 2nd and 1st point. You'll eventually see that this entire line OB has automatically got divided into 10 equal parts. The length of the line OB was 110. Therefore, 110 divided by 10, okay, for 10 parts will give you a length of 11 millimeters. So each division over here is representing a length of 11 millimeters to be very precise. Okay, let me do the marking properly, and here it is. Each division from this point until you reach here, that's 11. From this point to this point, that's also 11. So with respect to this O, this has got to be 22. With respect to this O, this has got to be 33, 44 and so on. Now, if I were to ask you, are you able to visualize a distance of 1 millimeters? You will be confused. Okay, you cannot see a division of 1 millimeter. Rather, you can say that you are watching a division of 10 millimeters, or you are watching a division of 11 millimeters. You are either watching a division of 20 millimeters, or you are watching a division of 22 millimeters. But guys, watch carefully. Let me just zoom into this and let me fit it in over here. You can clearly see that this is how much? That's 10. This is how much? That's 11. So 11 minus 10 is going to give you this small division over here. This small sort of lag between the two divisions is going to give you a length of 1 millimeters. Okay, let's repeat this again. This is 11, that's 10. 11 minus 10 will give you 1 millimeter. So in the same manner, you will also get 2 millimeters. Let me show you how. This distance between these 2 points, this red colored and this red color, that is 22. And between this O and 20, this distance is 20. So that's 20 and that's 22. Therefore, 22 minus 20 is going to give you this small lag. That is how much? That is 2 millimeters. In the same manner, this is going to be 3, that's 4 and 5, 6, 7 and so on and so forth. Right? So that's the idea. Okay. By now, you must have understood the concept of Vernier scale. And this over here, let me just color this. This yellow colored scale that you see is nothing but the Vernier scale. Okay, let us get into the detail. Let us involve a bit of mathematics to clearly understand this. One division of red scale will represent a distance of 10 millimeters. Yes, that's quite true. Now, one division of yellow scale is representing a length of how much? 11 millimeters. So the difference of first division of yellow scale and first division of red scale will be equal to how much? 11 minus 10, and that's going to give you 1 millimeters. Now you can say that the minimum length which this scale is able to measure is 1 millimeter, and this is something which has been achieved with the help of this shifted sort of a scale, which is a Vernier scale. And this over here, the minimum possible, the least possible length that your scale is able to measure is something which is referred to as a least count. You must have heard of this term, very popular term, and this is something that we associate with screw gauges and even vernier calipers. Okay, and finally, this yellow colored scale over here is nothing but your Vernier scale. So if you're this way through watching this video, I'm sure that you guys must have got a good idea as to what Vernier scale is and how this can be implemented to make a Vernier scale. So in the upcoming part of the video, you'll see two different examples where we are going to be making a Vernier scale, and this is going to be very, very simple, very easily achievable. Here we go. Problem 1. Okay. Now it states that draw a Vernier scale of RF is equal to 1 by 25. RF is equal to 1 by 25. So the original dimension has been reduced to 25 times. Okay, to reach centimeters up to 4 meters on it, and show lengths, okay, 2.39 and 0.91 meter. So the first thing that I'm going to write is all the given data. The first thing is this RF, that's 1 by 25. Okay, fine. That means the drawing has been reduced to 25 times from the original object, let's say. Now this scale should be good enough to measure up to 4 meters. So that's the maximum length. Now when you multiply maximum length with the RF, you automatically get the length of scale. So let's calculate it. Here we go. 1 by 25 into, well, this is unitless and this is 4 meters, that is maximum length. So automatically this length of scale will be achieved in meters. Now the scale that we are having, the physical scale, is in centimeters. So what you need to do is, you need to do a conversion. Meters can be written as 100 centimeters. So let's multiply this stuff with 100 and automatically everything will be converted into centimeters. Something like this. You just need to do this calculation. 25 times of, well, 4 is 100 and 4 is 16. That's all. Done. We now know the length of the scale on the drawing sheet. So the first step is to draw a horizontal line, perfectly horizontal, 16 centimeters. There you go. This is 16 centimeters. Okay. This height is 10 millimeters, and again this length obviously is 16 millimeters, right? So 4 meters in reality has been represented by a distance of, or a length of, 16 centimeters on a drawing sheet. So this 16 centimeters is 4 meters. So in order to see a division of 1 meter, what we need to do is, we need to divide this line into 4 equal parts. Listen to this again. This is a 16 centimeter long line, which in reality represents a distance of 4 meters. Okay, so in order to see a division of 1 meter each, you have got to divide this this into 4 equal parts, and this is going to be very simple. You can either use the line division technique, or you can also simply use a simple physical scale to do the division. Now this is 16 centimeters. 16 centimeters divided by 4 is going to give you 4, 4, 4, 4, like this. This is 4 centimeters, 4, 4, 4. Now each division in reality is expressing 1 meter. So what we are going to do is, we are going to place a 0 over here, and then over here we'll write 1, then 2, then 3. There you go. And here, that's meters. Okay. Now over here, the next unit, rather the next smaller unit to meters is centimeters. We'll put it over here, and automatically everything will follow. Don't worry. Now what? This is 1 meters. Let's say I want to see a division of 0.1 meter. What I need to do? Well, I need to divide this into 10 equal parts then. Okay, now listen to this very carefully again. This block over here is representing 1 meters. And in order to see a division of 0.1 meter, I need to divide this block into 10 equal parts. It's going to be something like this. So for 10 equal parts, you need to have 10 arcs. Let's say 5 millimeter radii arcs. That's the 10th arc. This arc has to be joined with the end of this line, something like this. Okay, and again the same process. You'll automatically see this division over here is 0.1 meter, and this entire division, this bigger division, is 1 meter, and this is 1/10 of that meter. Done. Very easy. Now if I say that please mark 1.1 meter, will you be able to do so? Well, you can do that. These 2 points are separated by a distance of 1.1 meter, no problem. But if I were to say you mark a distance of 1.14 meter, well, that's a bit tough. The scale is not yet ready to measure a distance of 1.14 meter, but we are going to make sure that this happens. How? Again, the same stuff. Let me just show you. Make the divisions, and at a height of say 5 millimeters, draw a horizontal line like this. What you need to do, guys, is you need to, with the help of a compass, you need to take this as the radii, and you need to mark divisions like this. Over here, here, here. Same divisions. These are the same divisions. You have to shift over to this division, this and this. Very simple, very basic. With the help of a compass or a rounder, you can achieve this. Now, this division is 0.1 meter, and what we want is a minimum division of 0.01 meter. How can that be achieved? Well, we have got to use a vernier scale. Now listen to this very carefully. This is 0.1 meter, and I'm going to produce a line from this point towards the left. Okay, this distance is equal to this distance. Fine, right? Now go 10 millimeters up from this point and 10 millimeters up from this point as well. Join them. Now what you need to do is, the number of divisions that happened over here were 10. The number of divisions which you need to do here also is going to be 10. Again the same process, the line division technique. Have 10 arcs. I have taken the length of these, not the length but the radii of these arcs as 5 millimeters. Do this. Very simple, very basic. Produce lines, vertical lines, drop vertical lines from all these division points. There you go. And now for more clarity, what I'm going to do is, I'm going to be erasing all this construction stuff. You guys don't have to erase this stuff. Rather, make sure that you do the construction in such a manner that it should be very, very light. Even if you write something above it with the help of a darker pencil, say for example, if you write centimeters or meters above that construction, it should be clearly visible, okay, contrastingly. Now, I need to use this zoom effect. Okay, so this difference. Okay, now this is 0.1, this is 0.11, this is 0.2, okay, and this is 0.22. This difference is 0.11 minus 0.1. You'll understand this in a much better fashion. Let me just have the values. Okay, something like this. This is going to be decimeters and this is centimeters. Why is this centimeters? Let me tell you. Well, 1 meter is equal to 10 decimeters. Okay, so a decimeter is basically 1/10 of a meter, and a centimeter is 1/10 of a decimeter. let me just have the values. So 10, 30, 50, 70, 90. Although I have written 10 over here, but you guys can just take it as 0.1 meter. And although I have written 11 over here, you guys can assume it as 0.11 meters. Remember, now what to do? We need to show on it a length of 2.39 meters. Length of 2.39 meters. Okay, scale is done. How can you represent this length? Well, it's going to be very simple. Just watch this. 2.39 minus. Now, from this vernier scale, this is the vernier scale on the top. Find me a digit which ends with 9. So obviously it's 0.99. Okay. So what you need to do is you need to minus this, subtract this. On doing, what are you going to get is this 2.39 minus 0.99. And this works out as 1.4. 1.4. Now the idea is very simple. 1.4. And when 0.99 is added to 1.4, automatically the stuff that you are going to get is 2.39, and it's something like this. From 0 towards the right, here we'll get 1.4, and to the left of 0 we have this distance as 0.99. So between these 2 points, the net distance is 2.39. Here we go. Let me just show you. You guys don't have to color this. This is basically for enhancing the drawing. Okay. If you're doing this on AutoCAD, go ahead and color it, no problem. That's 2.39. There is one more distance, 0.91. Okay, this can also be worked out, 0.91. So find me a digit, a number on the vernier scale which is ending with 1. It's 0.11. So 0.91 minus 0.11 is going to work out as 0.8. And when you add this 0.11 to 0.8, you will get this value, 0.91. It's as simple. So that's 0.8, and towards the left of 0 you have 0.11. So the distance between these 2 points is 0.91. I hope this is clear. Let us take up one more example and let us try to bring more clarity into vernier scales. Let's do this. Okay, so we've got a map, and this map is of 500 by 50 centimeter, right? It is representing an area of 6250 kilometers square. Construct a vernier scale to measure kilometers, hectometers and decameters, and long enough to measure up to 7 kilometers. So this over here is the maximum length, and representative fraction has not been given directly to you. So you have to work it out, and then this distance has to be measured. So let's write all the given data. Map area. So 5 into 5 is 25, followed by 1, 2 and 3 zeros. Centimeter becomes centimeter square. Fine. Actual area 6250. Okay. Now whenever sort of an area comparison is given, the RF has to be calculated using this formula. Let me show you. That's it. And this, by the way, is the maximum length. So drawing area, that's 25000. Actual area is 6250. Put it up. 6250 when multiplied by 4 will give you this 25000, and 4 centimeter square divided by 1 kilometer square, when they come out of the root, will become 2 centimeter by 1 kilometer. Again, the unit is different in numerator and it is different in denominator. We need same units so that they will cancel each other. Well, how can that be achieved? 1 kilometer is 1000 meter and 1 meter is 100 centimeter. So that is the conversion I am going to use. 1000 meter and 1 meter is 100 centimeter. You just solve this. This is very easily 1:50,000. So the original area has been reduced to 50,000 times in order to make sure that it fits in perfectly in a drawing sheet. That's it. That's the entire idea. Now let's go ahead and calculate the length of scale. Here we go. So this is the RF. Yeah, put it up over here. And the maximum length, well, that's 7 kilometers. Kilometers, we don't have a scale of kilometer, we have a scale of centimeters. I mean the physical scale that we use to draw lines and stuff like that. So kilometer is 1000 meter and meter is 100 centimeter. Just do this and the final value that you're going to get is, I guess it is 14 centimeters, right? Done. Again, so the first thing that we'll do is, we'll draw a line, okay? The length of the line is 14 centimeters, right? This 14 centimeter in reality is actually showing us a distance of or a length of 7 kilometers. So in order to see divisions of 1 kilometer each, you need to divide this line into 7 equal parts, and the process is very simple. Okay, use the line division technique, or just this is how much, 14 centimeters divided by 7 will give you 2 centimeters. So keep a scale over here, physical scale, 2 centimeters apart, keep on marking points, and this way you can have these divisions. At the end of first division, we'll put a 0 over here, and then in sequence 1, 2, 3, 4, 5, 6. Now the divisions are such that it is showing a distance of 1 kilometer. Okay, let's say I want a division of, as you can clearly see that this is 5.36 kilometers. So the scale should be good enough to read up to 1 kilometer, to read up to 0.1 kilometer, and to be also able to read up to 0.01 kilometer. How can this be achieved? So in order to, this has been achieved to make sure that your scale is good enough to read up to 0.1 kilometer, that is 1 hectometer. Okay, by the way, 1 kilometer is equivalent to 10 hectometers, and 1 hectometer is equal to 10 decameters. Okay, so this 0.1 kilometer can be regarded as an hectometer. Okay, just focus on this portion towards the left of 0. This is how much? That's 1 kilometer. So in order to have a division of 0.1 kilometer, we need to divide this into how much? 10 equal parts. We are going to use the line division technique. For 10 parts, I am going to put up 10 arcs. 10th arc with the end of this line. Use a drafter, keep on drawing parallel lines. You'll automatically see this has been divided into 10 equal parts. Now this division over here is representing 0.1 kilometer. Okay, now you can observe this. But I'm not satisfied with this. I want to make sure that I should be able to see a division of 0.01 kilometer. Will I be able to achieve that? Yes. I'm going to be using the concept of a vernier. I'll be using or rather making a vernier scale above this. So until now you can say we have made a plane scale, but now, so with certain modifications, we are going to convert this plane scale into a vernier scale, okay, by introducing a vernier somewhere here. Again, the process is very, very simple. From this point, you need to draw a line. Okay, but before that, let me just do this. Let me have all these markings, shift all these markings with the help of a compass or a rounder over to all these parts, here, here, everywhere. Done. Just watch the cursor, and I'm going to produce a line. Can you guess what the length of this line is? The length of this line is equal to 1 division over here. So you can keep your compass over here while the pencil end is going to be here, and then you can sort of make an arc, and then you'll have this division equal to this division. As simple. Then produce lines from this point and from this point in the upward direction. How high? Well, 10 millimeters. That will do the job for us. Done. Again, how many divisions did we do over here? 10 divisions. The same manner here also we are going to go for 10 divisions. Same line division technique, 10 arcs. Okay, 10th arc has to be joined with the end of this line. Keep your drafters aligned along this line, tighten the screw, bring it over to this 9th point, 8th point, and so on. There you go. Let me drop vertical lines from all these points. Done. Okay, now let me get rid of the construction stuff. Okay, so this is basically kilometers. Each division over here is representing 0.1 kilometer, which actually is 1 hectometer. Let me just write this: kilometer, hectometer, and here decameters. Now, let us watch this very carefully. Rather, I should initially write the markings. It's 10, 30, 50, 70, and this is obviously going to be 11, 33, 55, 77, 99. Now this small division over here is representing 0.1 kilometer. Okay, let me just again get back to this. This is 0.1 kilometer and this is 0.11 kilometer, such that the difference between 0.11 and 0.1 is going to be 0.01. Now you can scale. Now you can say that your scale is able to measure a minimum distance of 0.01 kilometers. Let me just touch upon that once again. This is 0.1 kilometer, This is 0.11 kilometer. So 0.11 minus 0.1 will give you 0.01. Okay. So now the scale is good enough to measure distances up to 0.01 kilometer or 1/100th of a kilometer. Okay. Fine. So the scale is done. Now what to do? Let me just add a bit of color to add a bit of life to the scale. Yeah. And now what do we need? We need 5.36. Again, the distance that needs to be measured is 5.36. So find me a digit on the vernier scale which ends with 6. It is going to be here, somewhere here. That is 0.66. So 5.36 minus 0.66. This is going to work out as, let me use a calculator, 5.36 minus 0.66. And this is precisely 4.7. So the idea is when you add 0.66 to this 4.7, you will get 5.36. It's as simple. So that's 4.7, and towards the right of 0, 4.1, 2, 3, 4, 5, 6, 7, that's 4.7. And when you add 0.66, so towards the left of 0 will exactly be here, 0.66. So between these 2 points, we have ourselves a distance of 5.36 meters, and here it is, done and dusted. So guys, after watching the entire concept and these 2 examples, I'm pretty much sure that you must have understood the concept behind drawing vernier scales, and you can also solve numerical problems from different books, maybe ND Bhatt or PS Gill. So guys, that was all for today. I'll see you again in the next video. Until then, take care, have a nice day, and happy Diwali in advance. Thanks for watching.